Hi, welcome to this tutorial. I'm going to solve question 10 from NECTA Form 4 2018 past paper. So the question involves solving quadratic equations, one of which is fractional equation. Now for 10a, we are told to use factorization method to solve the quadratic equation x squared minus 9x plus 14 equals to 0. So let's start with 10a. What do we have? X squared minus 9x plus 14 equals to 0. So I need to find two numbers that multiply to make 14, but when you add or subtract, they will give you a negative 9. So factors of 14, 1 times 14, this will not give me 9. And the other one is 2 times 7. So I can see these two numbers can give me 9. So I need to make this one negative 2 and this one negative 7 in order to get negative 9. So I'm going to rewrite that as x squared minus 2x minus 7x plus 14 equal to 0. Okay, so now I'm going to pretend there is a line there to separate those two, and I need to factorize this part and factorize this part and continue with my method. So with this first part, then the common factor is x, so I'm going to take x out and factorize it. So I'll have x negative 2 here. And then I need to bring this sign down, so it's negative. Common here between 7x and 14 is 7, and then x goes in and is a plus here, and I have minus, so I must have a minus inside. So to get 14, I needed 2 equals to 0. So one of these brackets, this bracket is common, x minus 2, so it's going to be x minus 2, and the other bracket is formed by using these numbers outside. So I have x minus 7 here equals to 0. So in order to get a 0, either this bracket is 0 or this bracket is 0, because you must multiply by 0 to get a 0. So you're going to say either x minus 2 is equal to 0, in which case x is equal to 2, or x minus 7 is equal to 0, therefore x is equal to 7. So your solution then, x is equal to 2 and x is equal to 7. And now for part B, we have 1350 over x minus 1350 over x plus 3 equals 5. So this number ends with 0, same with that, and not with 5. So I can see all these numbers here are divisible by 5. So I'm going to simplify my numbers by dividing by 5. So 1350 divided by 5, that will give you 270 over x, and then minus another 270 over x plus 3 equals to 5 divided by 5 is 1. Now these are fractions, so I must have the same denominator. So I'm going to multiply the top number by x plus 3, and then I will have x and then x plus 3 here, minus 270. I need to multiply this by x, so times x over x plus 3 equals to 1. And now I can join them up, so I can have, at the same time, I will take this out of the bracket. So 270 times x, that will give me 270x. And 270 times 3, that will give me 810. And then minus 270x. Everything divided by, I might as well multiply this out, x squared plus 3x equals to 1. So this is the same as writing 1 over 1. I'm going to, you can cross multiply, whichever method you prefer. So this times that is equal to this times that. So I've got x squared plus 3x is going to be equal to 270 minus 270x, that will go, equals to 810. Obviously, I can see it is a quadratic equation, so I must have a 0 on one side. So take away 810 to get rid of this 810 both sides. So x squared plus 3x then minus 810 is equal to 0. Well, I have here 810 and I need to get a positive 3. Now I can see 81 is actually 27 times 3. So I can see this is 27 times 30. And that is the factors of 810, 27 times 30. All right, so I need to end with positive 3, and I've got a minus in here, so one of them must be a minus. So plus 3, so I need to make that one plus, I need to make this one a negative number. So I have my two brackets then. I have my x there, that needs to be positive, so plus 30, and that needs to be negative 27. Okay, so in order to get a 0, one of the bracket must be a 0, this or that. So we say x plus 30 equals to 0, therefore x is equal to negative 30. Or then we have x minus 27 equals to 0, therefore x is equal to 27. Right, so you've got the two solutions, therefore x equals negative 30 and x equals to 27. So thank you for watching, and please press like and subscribe to my channel so you can get to see more of my videos. Bye for now.